Hey yo, let us make a statistical inference in approximately 5 minutes. What you are going to need is a working copy of Insight or NZ-Grapher, and you can obtain the sports science dataset from NZ-Grapher. The most important thing you're going to need is an inquiring mind. Please make notes, please feel free to fast forward and rewind at your leisure. Alright, let's get started. So, we are after an investigation. And here are our variables: target population, elite athletes in Australia, variable of interest, body fat percentage, and we are comparing gender. So the first thing we do is look at the dot plot, approximate and explain. We begin to explain the sample data. Let's have a look at the approximate shape of the distribution. For males it is skewed. For females it is normal or uniformly distributed. Now, a possible explanation could be that females are made for bearing children and therefore have a higher level of body fat compared to males. More research will confirm this and give you more information. Let's have a look where most of the data is, as measured by the standard deviation or the interquartile range. There it is for males, and here we go for females. Do you see anything unusual? What about these points? Further investigation is warranted. Lastly, there are our approximate sample medians. Next, let's begin to accurately identify and explain. Explain the sample data. Alright, here we go. These are the things that we saw before. Now, these unusual points are, funnily enough, sprinters, water polo players, and netballers. Now, further investigation is warranted around these athletes as well, because it is quite surprising that a netball player has a body fat percentage of 35%. An anomaly? Maybe, maybe not. Again, let's have a look at most of the data, as measured by the interquartile range in this case. And here are our accurate interquartile ranges. Now, upper quartile, take away lower quartile, will give you these numbers. Now, summaries are available in Insight or NZ-Grapher, or you could just calculate them yourself from the dataset. Now, the next thing we can see is we want to look for an overlap or a shift of most of the data. Now, what does that look like? Here we go. This green bit here, there's a gap between where most of the data sits. Now, you would expect most male athletes to be within that range of most of the data, within that 3.09 area, and you would expect most of the females to be within that 8.26% range area. Now we can compare the two interquartile ranges, and we can say that females are more spread out on average compared to males. Now, obviously, further investigation into this should reveal some interesting things. But the most important thing we're interested in is the overlap. Is there an overlap? Well, no, there's not. But there is a right shift of most of the data. So we're looking at the middle 50%, all those two blue parts compared. And the most important thing is the sample medians, 8.6% compared with 17.94%. Numerically, a large difference. Is the difference significant, or is it even statistically significant? Well, we'll have to wait and find out. Here we go. Now we look at this graph here. Okay, what are we talking about? Well, we need to account for variation. What is variation? When you take a randomly selected sample from any target population, your sample is only a small subset of the target population, mainly for practical reasons. But the issue here is, does your sample then accurately represent the population? Maybe, maybe not. Hopefully, yes. However, we need a way of accounting for this variation. We don't want the differences between the target population and the randomly selected sample, for example, people characteristics, to actually come into play here. So the difference between our sample medians is 9.3, as I've put on the screen there. Now, what do we see here? what we need to do is, ideally, we'd like to take another sample from the target population and compare our result. Now, for practical reasons, we can't do that, so we have a computer to help us do that. Computer simulation of random selection of another sample can allow us to compare the sample medians from the simulated sample with our sample median. Now, on this graph here, you should be able to see 5 different medians for the males and females. The dot plot that you see is from the 5th simulated sample. So if you compare the dot plots with the other screens, you will notice that there is a slight distinction. However, the most important thing to note here is that, hey, you've got resample medians compared with our median, sort of in a quite a tight-knit area for the males and the females. Now, what we want to do is we want to look for any overlap or shift. Are they in the same location? Well, in this case, there's hardly any overlap. There seems to be a significant distinction between the two. So we're looking at that right shift again. Now, let us take this to the extreme. Because we're using the power of computers, we can actually resample up to 1,000. So we're going to do the exact same thing we did on the previous slide. However, we're going to use 1,000. Okay, now we highlight the most concentration of the sample medians. So on average, the male resampled body fat percentage medians, they sit just under 10% and probably between about 5 to 10%. However, females sit between 15 to 20%. So automatically you should be able to see at least sort of a 5% gap between those two areas. Now this is leading us to something. There's that gap again. What does that gap mean? It's the final frontier. It's space. This is what you want. If you have this, you are highly likely to have a statistically significant difference between your two sample medians. Now, what we need to do is this. Let's interpret what we see. And here we go. I won't read that. However, and this is your inference. But let us conduct our final test. Let us see for sure, numerically, what our result will be. Alright, here we go. Here is a dot plot of the differences between the resampled medians. Remember our result of 9.3 and our 1,000 simulated medians? Well, there's our 9.3, and the rest of the dots are from our 1,000 resampled medians. The differences, of course, between the 1,000 resampled medians. And as you can see, there's a large concentration between that area. Hey, so what does this show us? What is so good about this? Well, firstly, most of the simulated differences are approximately close to our result, and we are far away from the land of no difference, the zero space, the zero land. Alright, lastly, let's make our statistical inference using a 95% bootstrap confidence interval. Our test results confirm that. Here we go. Boom. What do you think, people? Please make sure you use the numerical evidence there to give you the result that you need. Well, that was more than 5 minutes, but hey, sometimes we've got to do what we've got to do. Thank you for watching.